All right, thank you very much. I appreciate the opportunity to talk to you guys today. I want to tell you a little about UEC Electronics, what we do, and some of the solutions that we provide. UEC is a company in Charleston, South Carolina. We have 4 facilities in Charleston, and then we'll talk a little about the overall arching global company of UEC in a second. When you think about UEC, we do a couple different things. We do contract manufacturing, which is really taking entrepreneurs using our engineering services and engineering staffing to develop those solutions, and we develop those products for others. But what we're going to focus on here today is really our mobile power solutions. It is what we've developed with the Marine Corps, with the U.S. Army, to really provide renewable and make renewable solutions effective in the field. So just a little overview of what UEC Electronics is. So UEC Electronics is a 20-year-old company developed out of Cummins. Was actually acquired by Aerotech a few years ago, and we are the cornerstone of Aerotech's power division. So we are one of 3 brands that are represented in the power division. It's EFB, UEC, and then Epsilar. So between that, we have 7 facilities globally that we go out and we develop and distribute our products from. When you think about the 2 things where the evolution of our renewable products come, it really started in 2 ways. The first is vehicular power. So we actually did a lot of work and are doing a lot of work in service life extension programs for vehicles. So we'll do microgrids within a vehicle itself. So it's a dual CAN bus system. We take out all the guts of an aging vehicle, update it, and make it up to a modern technology standard. And the other piece that we really focus on is our mobile power development. So really the problem that we saw, or that we're trying to address, before I get there, I'll go to our expertise. So when you think about what we do from an expertise standpoint, and really what we drive to try to do well, it's using energy storage or using batteries to solve problems. So, there's power distribution, there's power management, there's software and intelligence to allow that to happen. But ultimately, what we look for is to use energy storage as that buffer. So when we have, what we talk about, solar being inadvertently produced or wind being produced or trying to optimize a generator, we can use energy storage to really maximize all that and use that in our intelligence to go forward. Which brings us to our hybrid power solutions. So the problem that we had in the field was that we're carrying generators out, we have a logistic fuel problem, we're trying to deliver fuel. The Marine Corps is really getting back to its roots of being expeditionary in nature, and they wanted a way to be able to utilize solar versus fuel for their solutions. So we developed what we call the green system. It's a 1 kilowatt system. It takes solar, storage, and generators and combines that into a working model. So really the intelligence behind the system is that we have a battery that takes the energy off the solar. We store that with our software. We make decisions on the load of how we want to operate that going forward, and then we provide clean power to the user. And I think that's key. One of the things we've seen in the field is that when users have a generator out there, it's very noisy, it's providing some power that doesn't optimize the equipment. We're able to use battery power to really provide that clean energy. We also take the energy storage off of the solar panels, store it, and then we can use an auto start capability for the generator, almost act like an UPS. So the generator will be sitting there. If the batteries are depleted, we're out of sun, we'll actually auto start the generator, bring that power in to charge the batteries back up, and run that generator in an optimal state. The result of this hybrid solution is something that is extremely mobile, that can be man-carried, provide power within minutes, 15 minutes we can set this up and have it operational, provides clean power, it's green, it's extremely lightweight, and it's incredibly modular. So we built this system so that we can add batteries, we can add solar, we can scale this from 1 kilowatt to 5 kilowatts with just a connector and a plug. So the idea is now we have a microgrid out there that can provide power where you couldn't have power before, you're having generator power before, and you're tethered with the logistical fuel chain. So the product line that we developed, so the original product we developed with greens, and now in the last year we've really focused on expanding that product line. We'll start with the largest system. So we developed a 10 kilowatt system. The idea here is we're taking and scaling up that system, that concept, to optimize generator usage, and now putting that into a field. So this will take a solar input, it'll take a 10 kilowatt generator, it'll combine it with a significant amount of energy storage, and can actually provide 3-phase power. So you're talking about significant power that's trailable. The nice thing about the 10 kilowatt system is if you need 3 kilowatts or you need a smaller amount of energy, this actually breaks down. So we can take this apart and man carry it similar to the greens. We can now do that with a 10 kilowatt hybrid system. So you have a lot of capabilities within this hybrid system. Understanding that there's a need for a variety of power levels. what we created was a 3.5 to 5 kilowatt system next. So the idea was, we can do 10 to 50 kilowatts of power on a trailable toller. Now we can break that down and we can do a man-carryable 3.5 kilowatts of power and provide power for those remote applications. A lot of these are towers, remote sensing, things that have huge power surges. We're able to put a system like that out there and leave it. The third system is the greens that we talked about. So, one thing, the other thing we wanted to point out is we can take any inputs here. We show solar a lot. We could use wind as an input. We can use different types of solar. We can use different amounts of solar. Really the intelligence of the system is around the software and how I understand my load and how I understand my end application and pull those two together. And then finally, we're just coming out next week with what we're calling the 300 watt, or we call it the Terp. It's a tactical edge renewable power system. So what this is you can barely see the box there, but this takes all those other boxes and it combines it into one unit. So now you have a 19-inch rack-mountable, very small box with energy storage, with DC to DC, with AC to DC conversion. So you have all the voltage outputs you want. Within 30 seconds, I can plug in a solar array and have the system up and running. And like for the example we found at NIE, we did a trial on a prototype of the system. We were out 35 days operating this system on a hill as a retrans site for a radio system flawlessly. Basically didn't have to have any refills. Where they were going back every 3 days and refilling a generator with fuel. So we were actually able to make a remote site that could be monitored, utilized, and controlled with the solar array, with the integrated battery system in the Terp 300. So we think this is a nice size for those retrans type sites, or if you're just going to go drop something and leave it, you can provide power indefinitely with a system like this. Okay. So uses, we talk about, a lot of people want to understand, I think the challenges we have with renewable, and the challenge we have integrating renewable into a hybrid system is building that confidence that people want to have, that they can be used. So, the more these systems have gotten out there, we have thousands of systems in the field now, as people start to use them, we start to get that data back, we can actually show that we can reliably make a system like this work and have the same capabilities you would the genset system. And you look at this, we have the ability to do surveillance, communication, comms. One of the biggest applications we have is clean water. So we're actually purifying water. And then in medical applications, we're powering medical equipment because the power is so clean coming off a system like this that we're able to handle very sensitive medical devices without issue. And ultimately, what we really want to get to is, what's the advantages of a hybrid system? Why would I choose a hybrid system? Where does it make sense? I think the real advantages come in three ways. One, it's cost reduction. We can put a real ROI into fuel savings on these systems. The larger systems, we've seen up to a 60% fuel savings by integrating batteries and solar with a system like that gives you a very quick payback on this system. The idea is we have power anywhere. I've created a microgrid. I can provide DC and AC power anywhere I need it, and I can have it immediately. It's easily transportable, and it's extraordinarily scalable. So if your need is a 300 watt system, we got a 300 watt system. If you need 2 kilowatts, we just tie these two systems together and they work from there. So between that and the silent capabilities, we're really seeing people being drawn to this type of a system where batteries can really be the way to be the buffer of a microgrid like this and make it effective. So just to give you a feel for it, it's gone through all EMI compliance. It's now an NSN item. All three systems are program of records that we've developed, and ultimately it's on GSA. So if you are interested and want to get really into detail, what we would ask people to do is let us understand your use case, let us understand what your load profile is. We'll design a system around it and use our system to hopefully power you out in the field. So that's UEC, and if you have any questions, certainly let me know. Thank you.